What do we see? All right. Hello. So what are we doing? We are going to be talking about the abacus. And we notice, hi, my name is Lynette. Welcome to my room. It is abacus time. We're talking about the math. And math is about this manipulative. This manipulative is called the abacus. So what we're going to do is we're going to count 1 and then 2. So we know what 1 and 2. That's what 2 looks like. It's easy to count, right? 2. And then there's 3. And then there's 4. 1, 2, 3, 4. Make sense? So what we're going to do is we are going to figure out how to do all of this. Oh, here we go. Here we go. Okay, so if we notice, we did 1, 2, 3, 4. Well, what about 5? Well, this is 5. When we do 5, hey, you got me at a good time. Woo! Hey, Dolce, welcome. This is cool. Hey, Rubber Duck, welcome back. Welcome back. All right. Yeah, Dolce. Okay, let me know if you have any questions. Okay, so what are we doing? We are, there we go. Okay, so look, if I do 1, right, and then when I add the 5, guess what? That looks like 6. So now we're doing this. Oh, no, we're not doing that one. We're doing this one. So we do this, we do 5, and then do 6. So if we do 1, and then we add the 5, that's 6. If I had 2, I have 1, 2, and I add the 5, now we're at 7. If I have 3, and I add the 5, that's 8. If I have 4, right, and then I add the 5, now we're at 9. Does that make sense? So what we're going to do is we're going to look at 10. Well, what does 10 look like? 10 looks like this. If we notice, 10 is a 1 and a 0. If you see the 0 is like a place value, the placeholder. 0 is a placeholder. So when we look, we have 1, 0, and 1. 0 and 1. And then if I do this, this is 1 and 1. So now we're looking at 11. After 11 is 12. Oh, wait, look, now we have 13. 13 looks very familiar, right? We've done 13. That's with the 3. So the 3 and the 1. The 3 and the 1. Thank you so much for the liking the lives. So we have 3 and the 1, and then we have 4. 4 and 1. 4 and 1 is 14. Now, how do we know what the numbers are? Well, when we look at it, right, we have the 10. And after we do the 10, this is 10. This is the 1 and the 0. The 0 is like a placeholder. When we look at it, we do this, 11, and then 12, and then 13, and 14. Well, what's after 14? Well, remember we had 15, 1, and 5. So when we look, we did 11, and we add the 5, now we have 16. If I had 12 and I add the 5, now we have 17. If I take away the 5 and I add 13, I have 13 and I want to add the 5, now I have 18. Greetings. Hey, Anne, blessing, welcome. You can download, I laminated these sheets. FYI, you can download and I laminated these sheets. Yee, what? Oh, great. That's fantastic. Okay, and then if I want to do 14, and then what's going to happen is I have add the 5, and now I have 19. So what does this mean? This means that the top bead, this 5 is always going to be, this top bead will always be the value of 5 no matter what. So what's going to happen is when we add the 5, this is now 19, we now can do 20. Notice it looks very similar to this, 2. So 2, and then that's 2, and then this is 2, and this is 2, and this is 2. But wait, why are we doing in different columns? Well, if you notice, the 2s actually have a set of, actually a placeholder. So the placeholder is the 1s, the 10s, the 100s, the 1000s, and the 10,000. When I look at it, we have 20,000. So when I write it, it's actually 20,000.00. So these over here is the decimal. We have our tenths and our hundredths. Notice that the decimal sits between the 1s and the tenths. Does anybody have any questions? Let me know. And so what we're going to do, oh, Anne, you know why I haven't laminated this because I'm still looking at the text. I found some other ones that I've done. This helped me tremendously. My son went, oh, really? The big brain notes? This one? That's fantastic. And then did they color it in? Because I remember, yeah, right? So if you laminated this and you colored it in, did that make sense? Oh, that's fantastic. That's fantastic. Okay, good. Okay, good. I was like wondering. I was like kind of thinking back a little bit. Now I get it. Now I get it. That's fantastic. Yeah, the blue and the red. Yeah, that's really good. And then when you talk about it, right, when he's counting, you can also go backwards, right? Just as I was talking about, we have the 1, and then if we add the 5, so it kind of remembers, right? This will be 6. So if I do 2, and then he will see that there's a pattern. If I do 2 and I add the 5, now we have 7. Yes, blue. Okay, good. Okay, good. Yeah, that's fantastic. And so then we do 3, right? We do 3, and then we add the 5, and now we have 8. So this is the one other way to reinforce how the 5 is the thing. Can you show addition and subtraction? Yes, Braden, I can. So making sure that we know how to read the abacus, then we can go on to adding, subtraction, multiplication, and division. We can actually do multiplication and division, but it just depends on how far everybody is. So when I do this, right, do we know what number this is? Let's test this out. What number do we think this is? So if I have my ones, my tens, my hundreds, my thousands, my 10,000, what number is this? Please put it in the comment. See? Let me think. Let's see. 1,000. It's late. It is late. 1,800, 5, 6, 7, 8, 1, and 7. Yes, 5, 6, 7. 1,817. Okay, good. So if we're okay, I mean, there's 17 of us and there's only 5 of us talking. So we can go into adding and subtracting. Are we ready for that? Yeah? Okay. We can do it. We can do it. We can do it. Okay. So when we're talking about it, the one thing we want to do is we want to understand how to move the beads. To move the beads, right? To move the beads. Oh, yeah. Okay. To move the beads, that was my old address. All right. So what we're going to do, because Braden wants to know, he wants to push the class forward, and it is getting late, and I want to see if I can move it all the way to multiplication, but let's see. So the first thing we're going to do is we're going to understand that we are going to look at the add-in. I lost my numbers. I lost my words. So what we're doing is we're looking at the add-in. I learned about the slide rule. It's amazing. Oh, hey, Josiah. Okay. I don't know about the slide rule, but that's fantastic. Welcome back, Josiah. Okay. So what we're doing is we're focusing on the add-in. When we focus on the add-in, we only want to know. We are not focusing on the result. So can I use this algebraic can I use this for algebraic topography? Topology. I don't even know what that is. That is way above my pay grade. So I'm not sure, Brock. I don't know what that is. That's above my pay grade. All I know is how to add, subtract, multiply, and divide, and sometimes with decimals. We are simple. We are very simple folk. You're absolutely. I'm such a simpleton. I really don't know what that is. That's really above me. So what we're going to do is we're going to add the 5. This is the 5. We know what that is, right, Braden? And then when we have the 1, we're just going to add the 1. So when we look at it, right, we only want to move the 1 bead. As we move the 1 bead, you'll notice I'm going to the horizontal bar and I go away from the horizontal bar. That means I'm taking away. I am subtracting. As we subtract, right, we add and we subtract. It's the same thing with the 2. When we add the 2, I want to go 2 beads to the bar and 2 beads away from the bar. So what's going to happen is, like just as I mentioned here, we're looking at the add-in. We want to have our 6, and my question will always be, do I have enough? Can I do it? Yes, I can. And that would be like a Bob the Builder thing, right? So the question is can I do it? Yes, I can. That's how simple I am. I like to relate to like movies that I've watched and television shows. So topology is really above my pay grade. So this is 2. We're going to add 2. And the question is do I have enough to add another 2? Yes, we can. So we're going to add 2. See? We're just going to add 2. So what we're going to do is we're just going to focus in on how to do the add-ins. And I don't know if Braden is still here, but we're going to continue on because what we're doing now is we're moving the beads. When we look at it, this is 5. This is the value of 5. And so I'm going to put 5 here. As I put 5, I'm going to do 3. When I do 3, I do 1, 2, 3. 3 at the same time. Not 1, 2, 3 because we're big people. So we know to be able to move the 3 beads. Okay, so as we move the 3 beads, our final answer is 8. Now, why is this a thing? This is a thing because we don't focus on the result. The reason why is because if the questions get long, you won't know what the answer is. So in abacus, it's very common to have more than just 2 add-ins. Sometimes we have like 3 or 4 add-ins. Like this. Sometimes we have 4 add-ins and you won't know what the answer is. So you would have to kind of do it in your head. That's why we focus on the add-in. So this one is 5. If I did 5 and then I add the 4. Do I have enough? Yes, I do. So all I got to do is add the 4 and my final answer is 9. Thank you for, is this your book? Yes, this is my book and it's on my website. You can download it or you can go to TPT if you want sections of it. So you can go to TPT if you want sections of it. I haven't broken it up on my website yet. The website is the whole thing. But for you, if you want to do like the beginning part is about bead recognition. And there are activities, right? So there's activities like this. And this is just, how does the bead look and what does the number look like? And this is the thing. Hello, Ethan. Welcome. Hey, Nat. Welcome back. Welcome back, Nat. So when I first started this journey on trying to modernize abacus, I was thinking that I was going to sell this book, and I thought that was it. But then I realized because I have you guys telling me that you guys want more, I have more books. So this book is available also here, and this is my name. This is my full name. Or you can find my website, and my website also has the printable copy. Or you can go to TPT. I should write TPT. Teachers pay teachers. Teachers pay teachers.com. So that's my store as well. So I'm trying to be kind of everywhere at once. There's that one movie, Everywhere. Yes, we're starting both at the beginning, and my son and I. Oh, yeah. I'm so happy for you. I'm so happy for you. I'm hoping when you go through the process, I'm explaining why you do things. Because I feel like I want to know why I do it, right? And that's how I try to teach. I try to teach, why am I doing this? Because I don't want to just memorize. I want to know why I'm doing it. So anyways, yeah. I have a few worksheets. I've been trying to do more worksheets. I do have this one where it's the maze, and this is about this is the maze, and this is about bead recognition. I'm about to do. Oh, thank you so much, Anne. I appreciate that. This one is a 2-digit, and this is just bead recognition. Again, it's trying to figure out, the path of the maze. And then I'm not sure if you remember this one, but then I had this little mask maze because Ethan said, we got to cover the answer. And I'm like, I don't even know how to do that. So then I thought about it, and I marinated on it, and I'm like, I made a mask maze. And this is available for download as well. Because then you can download it and you can print it out on cardstock. So that's what I did here. I used an old file folder because the paper that comes with the book is a little thin. So I was like, okay, you know what? We'll make this one as a free download. You just got to sign up for that one. But then there's this one. So there's 19 mazes this way. There's another way, which is a reverse, and I couldn't find the paper for that. I'll have to download that. Then there's also the 3-digit. I'm working on my 3-digit. I'm going to do 4 digits, and then I'm going to do 5 digits with decimal. So they're all going to be about bead recognition. And so that's what I'm working on right now. I actually just finished publishing this one, and this one's in, no, not this one. This one's in review in Amazon. But I shouldn't say that too often. So thank you so much, Anne. I do appreciate it. And I'm trying to make it interactive and not boring. And so that was one of the things, was like trying to also bring in the mainstream math kind of a thing. Okay, so we did adding and subtracting. If you notice, again, when we minus, we're going to take away the 4. So if I look at it, I go 4, I add the 4, and I want to take away the 4. Now my answer is 5. So notice, do I have enough? Yes, I do. So then what I'm going to do is I'm going to take away the 4 all at once. I'm going to use my index finger, and I'm going to just move the beads like that. So then that's what we're taking away. Remember that when we take away the bead, that means we're taking away from the horizontal bar. We're moving away from the horizontal bar. So then after this, we have the 5. So this is the preview. This is towards the end. This is lesson 11. There's only 12 lessons in the book. So in the book, I have like greater than, less than, counting forward, counting backwards, and then I have like I try to bring in more activities. So the other books will have more activities. So this one was you answer the question and then you find the answer piece on the puzzle. I like puzzles. So we have the 5 and we add the 5. Adding the 5 is the same thing. If I add the 5, I'm going to go to the horizontal bar. When I go away, it's subtracting. I go away from the horizontal bar. So then what happens after this is 6, right? And then we have 6. And then again, it's the same thing. If I want to add 1 and then I want to add 6, is there enough beads to add the 6? Yes, there is. All I got to do is add the 5 and add the 1, and I'm going to bring it together like that. That's what we're going to do. We're going to bring it together, and then we minus the 6, we take it apart. We bring it together and we take it apart. We bring it together, take it apart. So if you notice, when we know how to add, we will know how to subtract. And then we have 7. Same thing. We have 1, 2. Let's say we have 2, and then we add 7. 1 bead on top and 2 beads on the bottom. You bring together at the same time. When we take it away, right, it's taken away. This is minus 7. So when you go through, we can do 8. 8 doesn't have very many questions. You add the 1, and then you bring it together like this, and you take it apart like this. So that's about adding 8 and then taking away the 8. So then the 9 is the same. 9 doesn't have a lot of questions either because it's all the whole thing. So this is 9. And then there's take away 9, or there's adding the 9 and then minusing. So that's the same thing. And then after that, there's the minus, and that's it. So after you do simple, what does that mean? After you do simple, what happens afterwards? Well, what happens is when we don't have enough beads to do something. What does that mean? Well, if we have 4, or you know what, let's do 3. If we have 3, I don't want to add 4, what can we do? Notice there's not enough beads. Right? There's not enough beads to add the 4. What's the question? The question is 3 plus 4. So if I want to do 3, I want to add the 4. I cannot add the 4. So what do I do? Well, I know, what do I know? I know I have this thing. Ah, here it is. We're teaching children how to add 5, right? But that's as far as we go. We only teaching them how to add how to make a 5. 5 and 4 is equal to, 4 and 1 is equal to 5. 1 and 4 is equal to 5. This is what we're teaching children. But then what we're doing in abacus is we're going to take it one step further. Why? Because now we have a constraint. This constraint is I don't have enough beads to add the 4. So in order to add the 4, we're going to utilize our 5. We're going to make our 5s work. We're going to utilize our 5. And one of the questions was, and this was going to be, I want to add 5. I want to add 4. I'm trying to add 4. There we go. It's the very last one. So what I'm going to do is I'm going to add the 4. If you notice, I have my formula. No, I have my equation. So my equation is, what am I trying to do? Oh, there it is. I'm trying to find I need to find my, oh, here it is. Sorry. Okay. I like to protect my pages. So what we're going to do is we're going to take this and we're going to understand how to do it. What does that mean? Well, notice we have this 5. This 5 is what we're going to utilize. So my question is this 3, but now if I add the 5 is too much, right? If it's too much. So because I want to do is I want to add the 4. To add the 4, what do? I need to isolate the variable. I need to isolate this variable. To isolate the variable, would there be enough time? I'm sorry. Would there ever be a time where the blue bead is worth more than 5, or is it always 5 throughout? It is always 5 throughout. That's a very good question. It will always be 5 and 5 only, no matter what. So even if we did 6, right? 6 would be this. It would be 5 and a 6. It will always be 5. No, there is no ambiguity. There's no changes in that. This will always be 5 and 5 always. So what we're going to do is we're going to isolate the variable. To isolate the variable, we're going to make the 4 by itself. So what's going to happen is when we make the 4 by itself, notice that the 5 is too much. So as 5 is too much, how do we balance this equation? How do we balance this addition? To balance the addition, we're going to minus the 1. So what this is actually directions. This is directions on how to add a 4. So what we're going to do is we're going to plus the 5. That's what we did here. Plus the 5. And then here it says take away the 1. All we got to do is take away the 1. And my final answer is 7. So I hope that made sense, Dolce. So my final answer is 7. Now, yeah. So what we're doing is we're understanding how the beads are moving, how the numbers are working. And as the numbers work, you'll see that it's very versatile. So when we have the 4, right, we have 4 on our abacus and we want to add another 4, what's going to happen? Well, what we're going to do is we're going to add the 5 and take away the 1. So we're going to add the 5 and take away the 1. So what did we just do? We just practiced what we learned. And we have 2 other questions we can do this with. So what this answer is 8, because now we can read the number 8. Let's do another question. Let's do another question. We can do 2. And I always have to protect my stuff because I always keep writing on it. So we have 2. If we have 2, it's the same thing. If we have 2, what are we going to do? We want to add 4. To add the 4, we have this. And this is plus the 4 is equal to plus the 5 minus the 1. So what's going to happen? All I got to do is follow the directions. Plus the 5 and take away the 1. So my final answer is 6. So my answer is 6. 4 is nice because it's pretty versatile. We have a lot of numbers that we can add 4 to. Does that make sense? Are we okay? Yeah? Thank you, Nat, for liking the live. Are we okay? Does that make sense? Because then after we do this, right, notice we have another set. We have 3 more that we can 3 more that we can look at. And then if we look at it, it is the same thing. It's minus the 3 plus the 2 is equal to 5. So if I modified it, right, I want to make the 3 by itself. To make the 3 by itself, what do? I need to, 3 is equal to 5, but I need to make it equal. So if I make them equal, then I need to just minus the 2. So when I minus the 2, then what do? Then I can write here, what is a commutative property? So that means that if I do 3 equals 5 minus 2, I can do the reverse. 3 is equal to minus the 2 plus the 5. We should be able to do that. This should be something that's easy to change, right? And it's exactly the same. Now, yeah, we've done this, right? We've seen this before. This is very familiar, very similar to algebra, right? So because it's algebra, right, it looks very familiar, right? X is equal to plus the 2 equals to 5. Abacus is the gateway to complex math. And so what are we doing? Well, it's the same thing. It's because when we don't have enough beads, that's what we want to do. The biggest question is always going to be, do we have enough? If not, how do we do it? So here is the question. If I did this one, 4 plus 3. 4, if you notice, 4 on the abacus, and then I want to add the 3. I cannot add the 3. So what do? I will have to add the 5 and take away the 1. So I'm going to, take away the 2. So I add the 5 and I just take away the 2. So now my answer is 7. And that's what I got. So that is all about adding and subtracting the 5. That's about adding the 5. Now we can do the opposite. And now what we're going to do is we're going to compound our information. We're going to compound our equation. What does that mean? Well, we know that we have plus 3 is equal to plus 5 minus 2. Now we can do the opposite. That means we can do a subtraction. When are we going to do subtraction? We're going to do a subtraction when we have to do a takeaway of the 3. When does that happen? When we do 7, right? We have 7, and I want to take away the 3. To take away the 3, what do? We have to do the opposite, which is what? Which is this. To minus the 3, what are we going to do? Minus 3 minus 2. Same thing. What? Really? Yeah, same thing, but different. We're just going to change out our operators. So minus 3 equals to minus the 5. And then what do? This is not balanced. We got to plus the 2. So we're going to take away the 5 and we're going to add the 2. That's all we're going to do. So my final answer is 4. This is why we need to know how to do both. So now what we just did is we understood how to add the 3, and now we know how to take away the 3. See how they're very similar? So it's the same thing with the beads. We're going to, 4? Okay, we're going to add the 3 plus the 5 minus the 2, and then we're going to take away the 3. Add the 3, and then take away the 3. And that will be the pattern. Any questions? I don't know if Braden is still here. So, but that's okay. Make sense? So what we just did is we understand how to make a 5. Now, one of the things to do to make a 5, we have the others, right? We have the others, which is minus the, plus the 1 is equal to plus the 5 minus the 4. Or the other one is 2. Plus the 2 is equal to plus the 5 minus 3. So again, we need to remember that these are the partners. Cool? Okay, great. Anybody have any questions? So what happens? So after that, right? After that, okay, then the question is after that, well, what happens after that? Well, after that, right, we figured out how to add the 5. After we add the 5, now what do? Well, we need to understand how to add the 10. What does that mean? Well, in school, we're teaching the kids how to make a 10. When we make a 10, that's what we're going to do. We're going to utilize these formulas. We're going to utilize these addition sentences. These number sentences, where the equation, the expression, I don't know. I'm still trying to figure out those words. So what we're going to do is we're going to understand that they're pairs. Let's do this one because this one is very familiar with us. We know how to add the 4. Because we know how to add the 4, what are we going to do? What we're going to do is we have 8. So we do 8 plus 4. And I should do this so I can save my papers. So, okay. So what we're going to do is we're going to do 8 on the abacus. And when we do 8 on the abacus, we have 8 on the abacus, and then we add the 4. When we add the 4, can we do it? No, we can't. Can we add the 5? No, we can't. So what can we do? Well, what we can do is we can add the 10. But if you notice, the 10 looks like this. To make a 10, what are we going to do? We're going to 4, ooh, that doesn't make sense. 4 plus 6 is equal to 10. When we isolate this variable, we're going to do 4 equals to plus the 10 minus 6. Hello, Neon Panther. Welcome back. So what are we going to do? If you notice, this 10, this 0 is a placeholder. I think I'm going to use that a little bit. Why? Because 0 and a 10. 0 and 1. That's what 10 is, right? 0 and 1. I just ordered an abacus. Oh, that's fantastic. Welcome to the world. Welcome to the real world, Neon Panther. So we're going to plus the 10 and we're going to take away the 6. And all we got to do is take away the 6. And my final answer is 12. So what did I just do? Well, what I did was I figured out that there's a 5, right? We need to know that there's a difference between the 5 and the 10. That's it. Yeah, that's fantastic. That's kind of exciting. It's so funny how many people have ordered the abacus. It's really exciting. It's really exciting. So, all right. Oh, yeah. So we could do that. I mean, we could do 7. So it'll be 7. Same thing. We have 7, right? And then we want to add the 4. To add the 4, what do we do? Well, we know we're going to do this, right? Plus the 4 is equal to plus the 10 minus the 6. I'm going to plus the 10 and take away the 6. And my final answer is 11. Cool? Whew. It's a little late. Hello, Tech Druid. How are things? All right. Anybody have any questions? I don't even know if anybody's here anymore. There's 4 of us. There's 4 of us. There's got to be questions. Okay, there's only 4 of us. Is there any specific questions I can answer? Like, I don't know. I'm here. Yes, I see you, Neon Panther. Can we do some adding? Sure. Did you want to do a 2-step adding or you want to do 1-step adding? That's a question. What do we want to do? 1-step or 2-step? Because we can do both. 2-step. Okay, let's do 2-step. Okay, let's do 2-step. Hold, please. Okay, good. So let's do a 2-step. Yeah, okay. Because everybody knows how to use the abacus. I don't need to review the abacus if everybody needs to know how to use it. Ah, my little abacus came in the mail. Oh, yeah. There we go. Nice. Okay, so we're going to do our little, there we go. Here was a thing. You know what? Do you want to do this one? I don't know if this one's is what. Okay, is that too big? Maybe that's too big. Okay, we'll do 2-step. Let's see. Let me see if I can find some blank papers. I think I found it. There we go. There we go. All right. My little abacus. That's so cute. Okay, cool. Cool. Okay, we have this. All right. So the question is, what's the question? We do, well, okay. Let's do the, you know what? You know what? Let's see if we could do this one. We have 2, 7, 6, 3, 8, 9, 4, 5. How's that? Are we going to do that? Is that all right? It was just a question. Okay, let's try it. Let's try it. So on our abacus, we're going to have our starting point, right? We know our ones. This is 2, 7, 6, 3. Now remember, when we do this, we want to focus on the left. We're going to do the left side first. So the first thing we're going to do is we're going to add the 8. To add the 8, we know it's equal to plus the 10 minus 2. I like fat markers. I'm going to do there. Okay, let's do that. We'll do green. Okay? So what we're going to do is we're going to plus the 10, take away the 2. So we're going to plus the 10 and take away the 2. So I'm done with the 8. Now I go to the 9. The 9, is there enough? Plus the 10 minus 1. So then what are we going to do? We're going to plus the 10. Thank you guys, and minus the 1. So we're done with the 9. We're on to the 4. So the 4 is what? Let's see if I can do a different number, different color. So I'm going to add the 4. Is there enough to add the 4? No. Plus the 4 is equal to what? Plus the 5. Can I add the 5? No. Can I add the 5? No. So what are we going to do? What is the formula we're going to use? What's the formula we're going to use? Minus, we can't. Why? Because we have the 5 here. So we cannot add the 5. What's another formula to add the 4? Yes, thank you, Nat. It's plus the 10 minus the 6. That's the family. That's the making of the 10. So what we're going to do is plus the 10, take away the 6. And now I have this one, which is adding of the 5. Can I add 5? Yeah, I can add 5. See? There we go. So my final answer is 1, 1, comma, 7, 0, 8. That's it. Was that all right? That wasn't a two-step though. Okay, let's do a two-step. Let's do this one. This one's always fun. 49 plus 3. That's always fun. Because I know the numbers, right? We know that it's going to be definitely two-step. Why? Because when we add the 3, right? What do we want to do? We add the 3 is what? Can we add the 5? No, we cannot add the 5. So we cannot plus 3 here. What do? Plus the 3 is equal to plus the 10 minus 7. So we're going to plus the 10 minus the 7. Well, remember, we could do this. Minus 7 is equal to plus the 10. Let's do that first. Let's take away the 7 first. And then what are we going to do? We're going to plus the 10. Remember, when we add the 10 means that we're going to do a 1 and a 0. The 0, right? 1, 0. That's what this means. 1, 0. So we're going to add the 1. Do we have enough beats to add the 1? No. We don't have enough beats to add the 1. What are we going to do? Thank you, Nat. What are we going to do? If we cannot add the 1, what do we do? Hello, Monty and Lacey. Thank you. Yes. So because we need to add the 1, we have to plus the 5 minus the 4. So I plus the 5 and I take away the 4. So if you notice, that was the two-step equation. This and this is what makes it two-step. Does that make sense? Yeah. So when we look at it, we can do another one. We can do another one. Let's do another one. This is a fun one. I like it when I do 9s. When we do 9. Okay, you know what? We can do. Let's do subtraction, right? We do 103 minus 500. I'm sorry, minus 5. So that was a question we had. And I was like, oh my goodness. No, it's not oh my goodness. It's easy. Why? Because when we look at it, right, what are we going to do? We know to minus the 5 is what? Minus the 5 is equal to minus the 10 plus the 5. I'm sorry, I should do it the other way. It should be plus the 5 minus the 10. Why? So then we're here. Because we're here, we want to add the 5. So when we add the 5, we have to take away the 10, right? Take away the 1. Take away the 1. How do I know this is 1? Because if you look, 1 and 0, this is 0, this is 1. So my 1 is here. I cannot add 1. I cannot take away 1. How do I take away the 1? Minus the 1 is plus 9 minus 10. So I plus the 9, right? I'm going to add the 9. And then what do? I take away the 10. I take away the 10. Can I take away the 10? No, I cannot take away the 10. Hey, CV, welcome. So what's going to happen? Okay, so I'm focusing here. Hold on just a minute so I can finish my thought. So what are we going to do here? We're going to minus the 1. We can't minus the 1. What do? Plus the 9, and then take away the 1. When we take away the 1, right? Yeah, See, that's what I'm saying. Oh, this is my first subtraction problem. Oh, sorry. Sorry. You know what? That's the problem. I don't focus on subtraction, so I minus the 10. So my final answer is 998. Okay. Let's go back. Let's go back. So I forget how far we've gone. All right. CV. Is CV still in the house? All right. Let's do some. Is CV in the house? If not, I'm going to continue on doing subtraction. I wanted to do more subtraction because I know that I've, focused a lot about addition. Because it's easy to talk about addition, but we don't talk a lot about subtraction. CV's not in the house. I'm going to keep going. Can we do minus the 1 each row until... Yes, exactly. We do 10... Exactly. It's actually 10 minus 9. Okay, good. You're still here. No, I just want to make sure you're still here, CV. Because people come and go, and then they say, and then I'm going to go through this, and then they're like, oh, they left. I'm like, what? Okay. So no, I'm happy you're here. No, it'll be very quick. It will be very quick. I will tell you. Not a problem. I just want to make sure you're here. Okay, so the first thing we're going to do, CV, the first thing we're going to do is we're going to read the abacus. Now, when we read the abacus, right, anytime that the beads are touching this horizontal bar, this is the horizontal bar, this is the horizontal bar, this tracks our beads. So after we know how to track our beads, we know that this is 1. So after 1, 2, 3, 4, we know this is 4. Does that make sense? So when we look at it, right, we know that this is 4. Well, what happens after 4? Well, we have 5. So let's do 5. This is 5. All the top bead, right? All the blue bead will always be 5 no matter what. Always, always, always. So because this is 5, right, we know how to count. So remember, I had 1. But if I add 5, I have 6 now. Oh, good, you're still here. Okay, good. No, I do appreciate the comments, just so I know you're here. You know what I mean? Because it's difficult to know when people leave. So here, if I do 2 and I add 5, guess what number that is? That's 7. So again, if I look, I have 3 and I add 5, then I have 8. Does that make sense? So here I have 4, 1, 2, 3, 4, and then I add the 5. Now I have 9. Well, why am I here? The reason why I'm here is because this is my place value. Every place value, every column is a place value. So this is my 1s, my 10s, my 100s, my 1000s, my 10,000s. And when we are looking at it, we have 9. After 9 is 10. It looks very familiar, doesn't it? So now we're talking about number patterns. We know that this is 1, but if I move it over, now we have 10. If I move this one over, now we have 100 because it's 100. And if I again move it over, now we have 1,000. The reason why I'm over here, the reason why this is because I have this dot indicator. This is my ones indicator. You could use this one like a little Pokemon, right? You could use this one, but then I'd move everything over here, and then I will not have any hundreds. So that's why I move it back to line up my ones to this one, to this ones indicator. Does that make sense? So when we look at it, right, every column will be 9. That's 9. 9, 9, 9, 9, 9, 9, 9, 9, 9. That's it. So this dot, this decimal is sitting between the two place values. We have our ones and we have our tenths. And then we have our hundredths. So now we have cents if we were to talk about money. CV, thank you. I appreciate that. Some people don't think I am. Some people think I'm horrible. But that's okay. All right. So does that make sense? So what we're trying to do is what we're doing, the first thing we need to do is understand how to read the abacus. And then the second thing we're going to do is we're going to understand how to move the beads. And that's what we were doing is we were adding and subtracting. So that's why it was kind of a little bit confusing, only because it was coming in the middle of a conversation. But now that makes sense, right? And it's very easy. Abacus is simple to use and easy to understand. But the first thing we're going to do is we are going to, you know what? We're going to do some more, hey, Chumbum. Thank you. Did that make sense? Yes, you're clear it up. Oh, yeah, thank you. Thank you. I appreciate that. So now the first thing we're going to do is we're going to, let's do some subtraction. Okay, so the first thing we're going to do is understand how to add, right? We add 1, 2, 3, 4. When we did that, right, we're adding the ones. As we add the ones, it's going to the horizontal bar. When we want to take away, it's taking away, we're moving away from the horizontal bar. So what I just did now is I minus the 2. So I had 4 and I want to minus the 2. What we're doing is I want to focus, this time I'm going to focus on subtraction because I don't focus on subtraction a lot. So if I have 9 and I want to take away 6, I'm going to take these two beads, one bead on top and one bead on the one, and I'm going to take away the 6. Now, why am I doing it? Because I want to go through each and every scenario when we move the beads. The reason why is because we can see what we're trying to do. When we have this, I have 8. So I have 8, right? That's what 8 is. That's what 8 looks like, and I want to take away the 6. So in abacus, what we do is we focus on the add-in. We don't focus on the result. We don't focus on the result. We marry the process and divorce the result. Why? Because we don't know what the answer is going to be. That's why we use the abacus to help us track. So when we add the 1, we're just going to add the 1, and my final answer is 3. So what are we doing here is we're understanding how to add and subtract. So we could do it again with the -5. Now notice the way I do it, the way this book is broken up, is that we focus on the add-in. I want to teach the children, I want to teach whoever that how to add the 5. Thank you for the hearts, Chumbum. So when we do 7, and then I add the 1, I'm going to add the 1, and I take away the 5. When I take away the 5, notice I'm moving it away from the horizontal bar. So that's what we're trying to do, is when we go away from the horizontal bar, now we're doing a subtraction. Okay? So then what happens if there's not enough beads? Well, what happens is if there's not enough beads, that's when we start talking about formulas. When we start talking about formulas, the first set is this one, which is 4 plus 1 is equal to 5. This is what we're teaching children. But it's good because it's a core concept. It's a core concept in abacus. The reason why is because we focus on this add-in. We focus on the top bead. This is the top bead that's going to help us understand how to do things. So if I had the question 8 and I want to take away 4, to take away the 4, I'm going to reverse this. Minus the 4, I'm going to do -4 minus 1 equals to -5. Now what I'm going to do is I need to isolate this variable. Why? Because my question is 8 minus 4. My question is 8 minus 4. I'm going to isolate the variable. When I do that, now I got to do minus the 4 equals to minus the 5 plus the 1. Why am I doing that? Because now I know all I got to do is take away the 5 and add the 1. I have directions how to add and subtract. What we just did is we're understanding the core concept that we're teaching the children, and we're modifying it. We're leveling it up. As we level it up, we have these sets. This is a set that we can do. So what does that mean? Well, my little mini props that I have. So if you notice, we're going to do minus. So we did the -4. We did the -4. -4 is equal to minus the 5 plus the 1. Minus the 5 plus the 1. But then there's also -3. -3 is minus the 5 plus the 2. So how does that work? Well, if I had 6 and I want to take away the 3, I'm going to take away the 3. What do? Minus the 5 plus the 2 and go up at the same time. And my final answer is now 3. In abacus, we don't memorize doubles. In abacus, what we do is we memorize formulas. And these are the formulas that we would memorize, because I'll tell you a secret after all of this. So then we have minus the 2. Minus the 2 is minus the 5 plus the 3. And then the other one, the last one, is minus 1. Minus 1 is minus the 5 plus the 4. Does that make sense? So then, obviously, if there's a plus, if there's a minus, there's a plus. And they go exactly the same way, except the difference is the operations are the different, right? So there's a plus the 5 minus the 1, or minus the 5 plus the 1. Is that all right? Are we okay? Does that make sense? Should we do more adding of the 5? Yeah? Okay, good. Yeah. So this live session is dedicated to Nat, so we can talk about minus and subtraction. Okay, good. So what we're going to do is we're going to do the minus 10s. So after we do the minus 10s, right, it's the same thing. What do you mean? Well, just as we don't have just as we don't have enough beads to minus the 5, right? There is such thing as we cannot minus the 10. So here's the question. If I did 16 minus 7, oh, you can't see that. If I did this so you guys can see, right? We do 16 minus 7. When we do 16, I want to minus the 7. When I minus the 7, what do? I cannot minus the 7. I don't have any more beads to minus the 7. So this is where CV came in. I don't know if CV is still here, but what we're going to do is we're going to take away the 7. When we take away the 7, we don't have enough. What do? We got to look to our neighbor and borrow some sugar. So what are we going to do? Minus the 7 equals to minus the 10 plus the 3. So what do? We do minus a 7, it can't do it. Remember that 10, right, is a 0 and a 1. So all we got to do is take away the 1 because it's 0, 1. 0 is a placeholder. So I'm going to take away the 1 and I'm going to add the 3. All I got to do is add the 3. My final answer is 9. Does that make sense? So what we're doing is when we look at it, it's exactly the same, just the opposite, right? If I had 9 and I want to add the 7, if I want to add the 7, it's the opposite. I want to plus the 10 minus the 3. I'm going to plus the 10 minus the 3. I can minus the 3 and then plus the 10. I'm going to add the 10. Add the 1. I should say add the 1. I guess it'd be add the 1, but the 10 means that it's on the other side of it's the next column over. That's what that means. So we can do another one. We can do 11 minus 9. So again, instead of memorizing we all know what 11 minus 9 is, right? But in the abacus world, how do we do it? Well, in the abacus world, we're going to take away the 9. To take away the 9, what are we going to do? Minus the 9 equals plus 1 minus 10. What we're going to do is we're going to plus the 1 and minus the 10. So all I got to do is take away the 1 from here. And then my final answer is 2. Hey, welcome back, Blue Raptor. Okay. Oh, my answer is 2. So we can do another one. Are we okay? You want to do another one? We can do another one. Let me move my book. There we go. Hello, Roy. Okay. So we can do another one. Let's do this one. 13 minus 5. Right? Yeah. See, it's about practice, really. Right? It's really about practice and understanding where the questions come from. So here is 13. So I have 1 and 3. My question is take away 5. If I take away the 5, what are we going to do? I'm going to take away the 5 here. I can't take away the 5. How do we do it? Right? Minus the 5 is equal to plus 5 minus 10. So I'm going to plus the 5, and then what happens? I got to go over here and take away the 1. Take away the 1. My final answer is 8. So I think what really helps is understanding that this is a placeholder. This 0 right here is a placeholder, right? This is a placeholder. What do you mean? Well, if you look, that's 10. 0 and 1. So what's going to happen is if I do this, right? I'm sorry, 0 and 1. So then when I add the 1 or take away I don't need to say 10. 10 just means that this is 0 and then this is 1. I don't know. I got to figure that one out a little bit more. That's a verbiage thing. But yeah, if I look at it, the 0 is a placeholder. Yeah? Anybody have any questions? Wow, 7 people. Can we do the, yeah, let's do it. Let's do it. Okay, so the question is 1003 minus 5, right? We know what minus 5 is. So the question is 1003. And we need to minus the 5. Well, what are we going to do? Minus the 5 is what? Oh, you can't see that. There we go, right? Minus the 5 is what? Plus the 5 minus the 10, right? Plus the 5, so let's plus the 5. Now, if you notice, 10 is a 0 and a 1. So when I go over here, I don't have a 1. What's another way to minus the 1? What's another way to minus the 1? I want to minus the 1 here. Now I'm moving it. We want to focus here. I want to take away 1. How do I take away the 1? Minus 1 equals, yes, no, backwards. Plus 9 minus 10. So we're going to plus the 9 and then go to here. Can I take away 1? Can I take away the 10? No, I cannot take away the 10. So I go back to here. How do I minus the 9? I'm sorry, minus the 1. I can minus the 1. So what do I do? Minus the 9 plus the 10. So I'm add the 9 and then I take away the 10. Can I take away 1 now? Yeah, I can take away the 1. So my final answer is 998. Yeah. Yeah. And so that's the difference. That's all. That's it. That's the difference. And so it's kind of nice because you can see the repetition. Seeing the repetition of carrying the 1 or minusing the 1. Yeah. Does that make sense? Anybody ever? Yeah. Yeah, it helps to know that that was your first subtraction. No, thank you, Nat. Thank you so much for letting me know. I do appreciate it. But I'm happy that it's starting to make sense. And that's the thing, because we can see it, now we can ask specific questions as opposed to a blank page, right? A blank page is like, I don't know, you could do whatever. So thank you. Have a good night. Have a good night, Nat. I'll see you in my next live. Anybody else have any questions? We can go back and review if you like. Not a problem. I don't know where I've lost people. Division. You want to do division? Okay. If nobody else has objects, then we'll go into division. Okay. So we will go into division. I don't know what the obsession is with the division and multiplication. I'm not understanding this obsession. Why is that so woo? Thank you for the follow. All right. What we're doing, we're going to do division. We'll do division. Let's do division. We'll do division because nobody else is commenting. But thank you, Neon Panther, for being patient. I do appreciate your patientness. It's harder to grasp. I want to practice more. Okay, not a problem. Hopefully I can have the correct questions so it makes more sense. All right, so I just cleaned up my area. I think it's because that's where people begin to start. Hey, multiplication begin. How does it work with multiplication? Chumbum. Neon Panther, is it okay if we do multiplication first and then we'll go into division? Thank you, Ray. I do appreciate that. All right. Is it okay if we do multiplication first? I didn't know you guys are still here. You guys are so quiet. Okay, cool. Let's do multiplication. It will be easy. What? Are you sure? Yes. Yes. So the biggest thing in abacus, right, is to know your multiplication fact. And one of the things to understand your multiplication fact is why. Because, I don't know, 9 times 9 is redundant. 9 times 9 is redundant. After 9 times 9, 9 times 9 is as far as we go. And I don't know why we're told to memorize like 12 times 12. Like that doesn't make sense to me. But what we're going to start doing in our multiplication is distributive property. This is what we're going to do. Distributive property. Now, what does that mean? Well, we have our question 45 times that by 3. The first thing we're going to do is understand where our starting point is. So the reason why is because we need to know where our answer is going to lie. So when we count it, 1, 2, 3, I know that my answer is going to be somewhere around here. I don't know if it's going to be this way or this way, but it's somewhere like in the ballpark. It's a ballpark, okay? So when we look, what we're going to do when we multiply, we always go from outside. We always go left to right. So we go left, right, we go left. So 4 times 3. 4 times 3 is equal to 12. I add my 1, I add my 2. And then I do 5 times 3 is equal to 15. I add my 1 and then I add my 5. My final answer is 135. Yes, thank you, Neon Panther. So my final answer is 135. If you noticed, what I did was I didn't do it the way new math is. So new math would have done the way new math would happen, and I keep bringing it up because I don't know new math. The way they would do it is 40 times 3, and that would be 120. But when we do it on the abacus keeps track of it for us, so we don't have to worry about it. Does that make sense? 40 times, yeah. So that's the new math. New math talks about it, because what they do is they put it on paper. But because we have it on the abacus, we don't need to worry about 40, and there's no multiplication table above 12. So I don't know why. Anyways, I don't know why. But that's what it is. It is what it is. And so that's the one difference between the two. The difference between the two. So I feel like new math is like abacus math. Does that make sense, Chumbum? Do we want to do another one, or are we ready for the next one? We can do we can do we can do 2 digits. We'll do 2 digits. Yeah. Okay, cool. So what's going to happen is let's do another one. Now, if you notice, it'll be the same thing. The reason why we talk about it, the reason why I do a comparison is just to show the difference between what's being happened in school and how it works on the abacus. Some people have everybody, to each of their own. So if I do 36 times that by 92, I don't even know how that's going to work, but let's do it. So what we're going to do is same thing. We're going to count our digits. We have 1, 2, 3, 4. So 1, 2, 3, 4. Again, it's going to be somewhere around here. So the first thing we're going to do is, remember, we're going to do our left first. So left goes first. Left of the digit, left of the digit. So the question is 9 times 3 is equal to 27. Thank you, Neon Panther. Yes, 4 digits, and yes, thank you. Oh, yeah, thank you, 27. Thank you, 27, because it's getting late, and I sometimes get things wrong. So, what's next? Next is 9 times 6. 9 times 6 is 56? 54. 9 times 6 is 54. So I add my 5, I add my 4. 54. Good. Good. Thank you. Thank you, Neon Panther. So 54. I want to add my 5. I want to add 4. I don't have enough beads to add the 5. What do I do? Plus the 5 is equal to plus the 10 minus the 5. So I'm going to minus the 5 and plus the 10. This is why you need to know your addition first. Hey, Ruben, welcome back. So then we want to do 4. We add the 4, right? Now we're done with our 9. After that, we got to recount it. The reason why is because we're done with the 9. We don't need to worry about it again. So we have to recount. 1, 2, 3. 1, 2, 3. Oh, I see. So 3 times 2 is equal to 6. 6 is a single digit. So what do? I have to go back one column and I add the 6. There's not enough beads to add the 6. To add the 6 is equal to plus the 10 minus the 4. So I'm going to plus the 10 and I take away the 4. And then we have 6 times 2. 6 times 2 is equal to 12. Thank you, Neon Panther. So what's going to do is we're going to add the 1 and add the 2. My final answer is 3, 3, 1, 2. Thank you, Neon Panther. So that's what we are doing with the double digits. Thanks for your service. This helps me get sleepy. Yeah, you're welcome. You're welcome, Gonzalez. As long as it makes sense, I'm perfectly fine. Go to sleep and good night. I will see you in my next life. All right, so that's multiplication. Okay, we're done with multiplication. Now what we're going to do is we're going to do division. When we do division, let me see. How many ways can we divide? Let's see. Okay, this one's a good one. So what we're going to do is we're going to understand our divisor and our dividend. We have 4 divided by 276. Yeah. All right. So the first thing we're going to do is understand our starting point. What do you mean by starting point? Well, we got to know is we have our divisor. So we have our divisor. This is our divisor. And then we have our dividend. And I need to find my little label. Where's my little label? Okay, there it is. So a dividend. So we understand these are the terminologies, dividend and divisor. So when we're looking at the dividend and divisor, right, we're going to be comparing apples to apples. So as we compare apples to apples, we only compare to the one digit. That means I'm over here. Yeah. So that means I'm going to be talking about these 2 digits. I have this one and this one. Wait a minute. Before I do that, I need to know where to put my beads. Put the dividend. The reason why is because I need to understand how to make my how to make my answer. So my question is, I have 3 digits for that are dividend. So as my 3 digits are dividend, take away 1 digit is divisor. 1 digit is divisor means that my starting point is at 2. Does that make sense, Neon Panther? So my starting point's at 2. 1, 2 over here. Now, because my answer is going to be here, I am going to put my dividend on the abacus. I have 2, 7, and then 6. So after I have 2, 7, 6, now I have to do a comparison. My comparison is my divisor and my dividend. My divisor, I will say S, and my dividend, I will say E. My 4 is bigger than 2 or less than 2. My 4 is bigger. So if my 4 is bigger, then I'm going to take these 2 columns, the 2 and the 7. So now my question is, what times 4 is equal to 27 or less? Is it 6? Okay, good. 6. 6 times 4 is equal to 24. So what I'm going to do is I'm going to take away the 2 and I'm going to take away the 4. Cannot take away the 4. What do? Minus the 4 is equal to minus the 5 plus the 1. Minus the 5 plus the 1. So now what do? I have to compare my 4 or 3. Who is bigger, 4 or 3? My 4 is bigger. So that means, thank you, Neon Panther, that means what? I'm going to be utilizing these 2 digits. These 2 digits, 36. So 4 times what is equal to 36 or less? Is it 9? I think it's 9. Yeah, I think it's 9, right? 9? 9 times 4 is equal to 36. Thank you. Okay, good. So 9. I take away 30 and I take away 6. So my final answer is 69. 69. That's my final answer. 69. But see, the reason why we put it on the reason why we put the dividend on the abacus is so then it helps us track our answer. Wow, thank you for the likes. Yeah? We all right? Cool? Okay. How are we doing? So is S bigger? So if the S was bigger, then it would be start where? First time I see you do division, I didn't expect it to be so much. It is a little much. Division's a little bit more. Division's a little bit more. But you know what? Division's more having a conversation with your question. So if the S is bigger, then it would be start where? Oh no, if the yeah, that's what it is. If the S is bigger, you start where you are and then you subtract, right? Or you start closest to the dividend. So when we had it, right, it was like 36, then it would be over here next to the dividend. So if the S is bigger, you'd be next to the dividend. So if we had something like this, I don't know what number this would be, but if you had 600 and then I had number here, then it'd be whatever here is, then my answer would be here because my S is bigger. So what if E is bigger? If E is bigger, then you would skip one and subtract one or eat one. So we skip this one and we go here. We would only subtract from the one column. So that's the difference. Those are the only two difference. So if the divisor is bigger, if the S is bigger, then you use two columns. If the E is bigger, then you want to skip one and subtract one. Yeah. Yeah, I haven't really broken it down like how it looks here. But that's how it is on the abacus. And it makes more sense to me on the abacus. But to translate it to like mainstream math it takes a little bit. It takes a little bit. Yeah. But you know, Ruben, actually if it's any consolation, these are the two things that we need to do. That's it. Everything else is we have to know, right? We should know how to add and subtract. We should know how to multiply. Right, so let's do that one. So we could do that one the other way. The other way? This way? So we have 2 divided by 476. Again, we need to know our divisor and our dividend. With our divisor and our dividend, we're going to start comparing. No, we're not comparing. We need to find out our thing. We need to find out our starting point. To find our starting point, 1, 2, 3. So there's 3 dividends minus 1 divisor is equal to 2. So our place value is 2. Because our place value is 2, now we're going to do is we're going to put our dividend on the abacus. So we have 4, 7, and then 6. Now what we're going to do is we're just going to subtract. We're going to multiply and subtract. We have our divisor is 2. Our dividend is 4. Now our dividend is bigger. So what we're going to do is we're going to skip this column and we're going to go here. That means we're only going to utilize one column. We're only going to do a subtraction for this one column. So the question is 2 times what is equal to 4 or less? 2 times 2. So I'm going to add 2 here and I take away 4. Yes, thank you. Thank you, Neon Panther. So now we do it again. We have to compare. Who is bigger? 7 is my dividend. 7 is my dividend, or my divisor is 2. Which one's bigger? 7 is bigger. So again, I have 2 times something is equal to 7 or less. So I skip this column and I go here. And I add my 3. And then I take away 6. Why? Because 2 times 3 is equal to 6. So I take away 6. Now I have to compare again. What am I comparing? I compare my divisor is 2. My dividend is 1. Hi, Audrey. Hey, Audrey. Are you still awake? Why are you still awake, Audrey? So I have 1. So 2 is bigger. Because 2 is bigger, what are we going to do? We're going to utilize these 2 columns. These 2 columns, right? 2 times what is equal to 14 or less. I just ended my, oh my God, Audrey. Hey, Audrey, you know what? Let's see if I can do this. 7. I was going to, you want to come on? Do you want to come on, or are you too tired to come on? I'm just playing around now. Because I got this thing. I don't know. Anyways, so what is my answer? 7. I need 7. So yeah, that's my final answer. So my final answer is 2, 3, 7. Is that right? Oh, I did that wrong. That was supposed to be 6. Oh, 8. It's supposed to be 8. Sorry, 8. I got carried away. No. It's 8 because it's 6. 16. It's 16, not 14. Sorry, that was my bad. So it's supposed to be 2, 3, 8. Yeah, my bad. 2, 3, 8. It's getting late. It's an 8. And then there's 6. Yeah. I mean, yeah, anyways. But yeah, that's what we do. So that's the difference, right? If the divisor is bigger, then you take 2, you utilize 2 columns. If the dividend is bigger, then you only take the 1 and you skip 1. That's the only right now, that's the only rule that we need to memorize. Yeah, this makes sense. Thank you. Not a problem, Neon Panther. Not a problem. Tumbum, you all right? That's a funny name. Okay, what are we doing? Are we going to do some more? We can do some more. Okay. I would love more. I'm still kind of lost. Oh, okay, Ruben. Did you understand multiplication? And then we can take it a little bit slower. We could do this one. This one's a good one. Okay, let's do this one. I'm sorry, downloading my live. All right. Oh my gosh, you're so funny, Audrey. Okay, you know what? Let's do this one. You know what? Sometimes it's the numbers. If the numbers are too big, right, then we get kind of confused. So let's try this one, which is 32, right? 132. 2 divided by 132 divided by 2. So let's try that. Maybe that would be better. Because sometimes I know for me, if the numbers are too big, then I get kind of wrapped up in everything. So here's the question. Where do I start? I start at 2 because it's the same, right? Because I start at 2. What am I doing? There we are. Okay, I'm going to start at 2. 1, 2. So I'm going to put my dividends here. 1, 3, 2. Okay, so now I have my dividends here. So I don't need to look at this anymore. I'm going to just look at this. So when I make up my chart, it's divisor and my dividend. So my 2 is my divisor. My dividend, what number is my dividend? I only want to compare the one number, right? So 1. My divisor is bigger. Because my divisor is bigger, you can't divide, thank you, Neon Panther, you can't divide 2 into 1. That's why you need to use the second digit. Does that make sense? So the question is now, 2 times what is equal to 13 or less? Or less. 2 times 6? Yeah, thank you. 2 times 6 is equal to 12. So I bet 6 is here. And then I take away, I minus 13. I'm sorry, minus 12. Minus 1, minus 2. And now I'm back again. My divisor is 1. I'm sorry, my dividend is 1. My divisor is 2. Again, my divisor is bigger. So my question is 2 times what is equal to 12 or less? 2 times 6. So I add 6 here and I take away 12. Take away 1, take away 2. So what we did is we're doing subtraction on the dividend on the abacus. So my final answer is 66. Yes, thank you, Neon Panther. Did that help a little bit, Ruben? It also matters on what the numbers are too. So for right now, usually the numbers will always have a zero. So we can do another one. Hey, Jesus. Hey, Jose. I think I understand, maybe. Yeah, division's a little bit because we don't do division too much. And so doing this is still a brand new concept. Like I don't divide very often just in general. Like we don't divide very often. We do a lot of multiplication in our life, but I don't think we do a lot of division in our life. Okay, so let's do another one. Let's do another one. Are we ready for another one? We can do 7 divided by 203. Right? So again, I mean, we know how to compare. We know how to start it, right? We know we're going to be the second one. What? How do we know? Because it's 3 dividends minus 1 divisor. So we're at 2. 1, 2. Because it's 3, take away 1 is 2. So we're here. Because my answer is going to be here, I'm going to put my dividend on the abacus. Thank you for the heart, me, Audrey. So I'm going to put 203. Notice I'm not worried about place value on the abacus when I put my dividend. Just so you know, I'm just trying to make it as obvious as possible. We don't care that this is 2.03. We're not worrying about that. What we're worried about is that this is just a placeholder. Does that make sense? So because it's a placeholder, now we can divide. Now the question is our divisor is 7. Our dividend is 2. So if our dividend, who is bigger, our divisor or our dividend? Because our divisor is bigger, we need to actually have the second number because you cannot divide 7 into 2. So that's why we need the second number, which is 0. Does that make sense? So now my question is 7 times what is equal to 20 or less? 7 times 2 is equal to 14. I add 2 here, and I take away 14. Take away 1, take away 4. Minus the 4 is minus the 5 plus the 10. Now we're comparing again. 7 or 6. So I have 6 here. Who's bigger? 7's bigger. Now what I do? So now because 7 is bigger, I cannot divide 7 into 6. I need to grab the next digit, which is what? Which is 3. So I got to do 3. 7 times what is equal to 63 or less? I think that's 9, right? That's 9. So I put my 9, and my final answer is 29. So I do 29. Yeah? Does that make sense? Cool. Okay, let's do another one. Are we ready for another one? Excuse me. All right. We can do, I think, 3117. So now what are we going to do? Same thing. We have our divisor, our dividend, and we have our divisor. And then we're going to lock our dividend 1 2. We put 1 1 7. And then I'm going to thank you for teaching me something new today. Yeah, not a problem, Ruben. Have a good night. Have a good night. Thank you for stopping by. All right. Are we ready? So what are we doing? Divisor and our dividend. 3 is our what? 3 is our divisor. 1 is our dividend. So who's bigger? 3 is bigger. So we need to look. 3 times what is equal to 1? Cannot do it, right? We got to get the second number. We got to get the second digit, which is another one. So 1. Our question is 3 times 3 is equal to 9. So I add my 3 here and I take away 9. Thank you, Neon Panther. So I take away 9. To take away the 9, what is it? Minus the 10 plus the 1. Now what do? We compare again. 2 is my dividend. 3 is my divisor. So when I look, right, 3 is bigger. Why? Because I cannot divide 3 into 2. I need the second number. I need this number. That number is 7. So 3 times what is equal to 27 or less? 3 times 9. Thank you, Jose. Take away 2, take away 7. Does that make sense? We're all right? Yeah. Oh, so my final answer is what? My final answer is 39. I think that's a better way. I don't know. I think trying to line up the question, I think, is a better way. I'm trying to figure out an easier way to teach this. But I don't teach it very often because usually the kids kind of drop off. Let's do this one. Okay, let's do that one. We have 4 1 4. Hello, Manny. So we're going to do our divisor and our dividend, right? We know we're going to be here. So it's 1, 8, and then 4. We have to compare. Divisor, dividend. Divisor is 4. Dividend is 1. So what's the question? 4 times what is equal to 1? That doesn't make sense. We need the second digit. So we need to know, right? We need to know 8. 4 times 4 is equal to 16. So I put the 4 here and I take away 1 and I take away 6. Now what are we going to do? Same thing. 4 or 2. This is the 2. Who's bigger? 4 is bigger. So when I line it up, I'm going to do 4 times what is equal to 2. But that doesn't make sense, right? We need the next number. We need the 4. We need the 4. So 4 times what is equal to 24 or less? 4 times 6. Thank you, Neon Panther. Is minus 24. So my final answer is 42. Excuse me. Yeah. Wow. There's a lot of people. Okay, good. Yeah, it makes a lot of sense, right? There was others. We can do another one. Yeah. And that's what it is. It's a lot about like practicing. Oh, please. So those people that came in, anybody have any questions you want to review? Anybody want to know how to read the abacus? We can read the abacus. So here we're going to read the abacus. We're going to go 1, 2, 3, 4. Because the beads are touching this horizontal bar, this is what's 4. So if you look, this is 1. But now we have 5. The top bead will always be 5. And so when you look, this is 5, and then this is 6. Tap during the review. Oh yeah, please tap when you get a chance. Please tap out the screen. So when we do 1 and we add the 5, now we have 6. If you notice, we have 2 and we add the 5, now we have 7. We have 3, 1, 2, 3, we add the 5, now we have 8. We have 4, and then we add the 5, now we have 9. So what's after 9? Well, we have 10. Looks very familiar to this one. This 1 and this 10 are very similar. It just depends on the place value. So every column is a place value. So we have our ones, our tens, our hundreds, our thousands, and our 10,000. So right here, we're at the tens. So now we can count by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, and then we have 100. That's it. Anybody have any other questions? But I think it is time. Oh, that's a good one. Let's do that one. Okay, Neon Panther. I will accept your challenge. Okay. However, we might have to change the abacus. So the difference is now, whatever we do to one side, we got to do it to the other side. Because what we do is we do partial quotient, I think it's called. I think it's called partial quotient. I'm not sure. But the first thing we're going to do is find the abacus. Because I don't know where it's going to be. So we're going to count 1, 2, 3, and then 1, 2. So we know our starting point is at 1. We're going to put our dividends onto the abacus. Our dividends and our divisor. So we're at 1, 9, 3, 6. That's what we're going to do. So what's going to happen is we're going to compare. We still compare apples to apples. We still compare 9 to 2. Doesn't matter. We still compare it. So what is it? It's S and E. 2 or 9. Who is bigger? My dividend. Because my dividend is bigger, right? The 9's bigger. What do? We only need to skip this column and we're here. So my question is 2 times what is equal to 9 or less? We don't need to go any higher than this, right? So 2 times 4 is equal to 8. So I add 4 here and I take away 8. So now my questions is what? Well, I'm going to compare 2 and 1. Who is bigger? My divisor is still bigger. My divisor is bigger. So if my divisor is bigger, then I'm going to be here. My question is 2 times what is equal to 1? And then don't forget, they can't do this, right? You got to do the next number, 3. So 2 times 6 is equal to 12. I add my 1 and I take away 12. Oh, sorry. I'm sorry. Sorry. I forgot. This is where I'm getting late. Okay, wait, start that over. 1, 2, 1. Okay, 9, 3, 6. So what we're going to do is 2 times 4 is equal to 9. 8. 8. Okay, this is what I missed. Whatever you do to this side, you got to do this side. So 4 times 4 is equal to 16. Take away 1, take away 6. Cannot take away the 6. Now we're going into this thing called breaking the quotient. We're going to take 1 from the answer, go back 2, and add the divisor. So now 3 times 4 is equal to 12. Take away 1, take away 2. Take away 2. That's not right. I messed something up. No, that's right. No, that's right. Okay, so who's bigger? The dividend is 4, and our divisor is 2. Our dividend is bigger. That's not right. I messed something up. Sorry. Now it's getting late. Now I'm feeling it. 1, 2, 3, 0. Here. 9, 3, 6. Who is bigger? Oh, I didn't skip. So 4, I add the 4, I take away the 8. Whatever the do here, 16, take away 1, take away 1, take away 6. Take away 1, take away 6, take away 1, cannot. So let's go back 2, and then add the, okay, got it. So now 4 times 3 is 12. Take away 1, take away 2. That's better. So now we're back on track. 2 times what is equal to 1, right? Who's bigger? So 2 times what is equal to 11 or less? 2 times 5 is equal to 10. I add the 5, I take away the 10. And then because I do 5 here, I got to do 5 here. 5 times 4 is equal to 20. Is there enough? No, there's not enough. So what do? Take 1 from the answer and then go back and add this number. I'm going to add this number. So 4 times 4 is 16. I'm a little quiet because I think I'm doing it wrong. So I think I'm doing it wrong. Who's bigger? 2 or 2? They're both the same, so you go to the next one. 2 or 4. Divisor is bigger, so then you know. What? Then you know that you're going to be using this. I don't know. I broke you. Yeah, it's late. It's very late. I think I'm trying to. I can't think right now. 2 times 2 is 1. So if I have 1, take away 1. Can't do it, so I take 1 from the answer, go back 2. That doesn't make sense. I don't know. I have to figure that one out. Now I have to figure it out. It doesn't even. I don't even know if it divides out. Whew. 1, 3, 6 divided by 24. 39. 39. I don't think I did that right. Okay, let's try that again. All right. Yes, this will definitely be my last one. All right. Let's try it one more time. Let's try it one more time. Okay. Let's try it one more time. Just you and me. Okay. Okay. I don't know. I don't know who else is here. But thank you. I do appreciate that. 24 divided by 936. Okay. So we know we're going to be at the 1. So we're going to be here. Now, if you look, we're going to compare 1 and 1. So 2 and 9, S and E. So what's going to happen is, guys, skip 1, eat 1. So what does that mean? Oh, I have to put my 936. Okay, so I'm going to skip 1. 2 times what is equal to 9 or less? 2 times 4 is equal to 8. So I add my 4, I take away 8, right? So now 4 times 4 is equal to 16, but I have 13. Can't do it. So I got to take 1 from the answer, go back 2. That's my problem. Go back 2, and I add the 2. So 4 times 3 is equal to 12. So I take away 1, take away 2. There we go. There we go. Okay, got it. So now we're going to compare again. 2. So if I compare again, S and E. 2 or what? 2 or can't do it. 2. They're not. They were the same. So you got to go to the next one over. We have a 4 and a 1. So this is bigger. This is bigger. So if this is bigger, then the question is 2 times what is equal to 21 or less? 21 or less. Why are we doing that? Well, because we need to know that 2 times 9 is equal to 18. So 9, and then take away 1, take away 8. Take away 8 is what? Minus the 10 plus the 2. There we go. So then we have 4 times 9 is equal to 36. So then our final answer is 36. There we go. I'll have to clip it. That's what it is. Because the problem is, so the question is why am I doing 2 here? The reason why is because the divisor is bigger. Because the divisor is bigger, you still need to take 2 numbers. You still need to take 2 digits. Because you take 2 digits, it doesn't matter. You can only go as high as 9. So that's why it'll be 2 times 9 is equal to 18. So then our final answer is that. Yeah. Thank you. It can be solved. It just depends on it. You should read the problem and post it for me. Yes. You know what? I will redo it. And clean it up better. Yeah. Let me redo it and I'll clean it up. And so what happens is the one thing is there's the thing to go back to reduce the quotient. I was trying to think of another way to do it. Somebody was saying like to break the quotient. But I don't think that's a terminology in mainstream math. You know what I mean? Like in mainstream math, you take the 2 numbers and you try to figure out how to divide it. So we don't actually have that same problem in abacus, because in abacus what we do is we break it up between this digit and this digit, so we get partial quotient. I think that's what you call it. I haven't done too much research on the dividing. But yeah, let me clean it up and I'll post it, because there was another one where Alma was asking about percentages, and so I remember how to do this now. But that's the one thing is that we would have to break it up, because the way we do it is we take one after the other. Thank you, Audrey, for the team bracelet. So yeah. Yeah, I do think it's time for me to head to bed. It is 11. It was a little bit, but yeah, when I start making mistakes and I get lost, I know that I'm tired. So other than that, thank you so much. Yeah, Audrey, I can't believe you're still awake. Yeah, you and Neon Panther are in the same time zone. Oh my goodness, you guys, midnight math, I'm telling you, midnight math. Whew, you guys are crazy. So, and people are still coming in and out of the room. It's like, okay, hello. Okay. If there's no other questions, yeah, I'll clean this up and I'll post it. It'll be fine. It'll be good. The one problem is that we have to break the quotient, and I don't think that's a thing in mainstream math. You know what I mean? Like, how do you do that? How do you do it in mainstream math? Yeah, see, you guys are in the same area, same time zone. Crazy. Okay. All right. I am going to sign off. Thank you again for attending. Thank you again for the comments, and I will post this as soon as I can. Um, but I guess that's the question is I don't think there's another way to do it, right? Yeah. Have a good night, Neon Panther. I'll see you in my next live. Yeah. You okay, Audrey? You all right? Just tapping. Start co-host. You can now invite up to. You know what? I'm gonna make you co-host. It is tough trying to. Who is? Where is? I don't know how to do this. Here, my friends will appear online. Send. Refresh. I'm trying to figure out how to make you a co-host, Audrey. I don't even know how to do this. This is kind of cool. Send to who? No, cancel. I don't see you. No, that's not it. Okay. No, maybe it's a multi-guest. Ah, there we go. Accept. But multi-guest is different. Co-hosting. I don't know how to do co-hosting. Trying to get to. Oh yeah, thank you, Neon Panther. Why are you still awake, Audrey? Oh my goodness. Oh my gosh. I can't believe you're still. I was like, oh my gosh. When I saw you, I was like, oh my gosh. So late. Neon Panda, do you want to join us? So, you alright? Yeah? Neon Panther. Hey, Atticus. Welcome, Atticus. Hello, Neon Panther. I don't I I don't bring people on very often, but because it's only us. I'm returned. Atticus, welcome back. Atticus says that I'm talking about him all the time. Hilarious. I was going to do a post about him, but I couldn't figure out how. Oh, sorry, that was me. Yeah. What is Atticus doing up so late? But we are talking about Atticus and dividing. So I don't. Yeah. So, anyways, yeah. Okay. Yeah. All right. I think so. I think so. Yeah. You know what? You know what I want to do? What I want to try to figure out is how to do a battle. I've been seeing these people do battles. Sir Patrick, nice seeing you too. Sir Patrick is the other person. I think he's in Uganda, and we follow each other. Good morning. Good morning. It's morning. Yeah, he does. He like has a whole abacus class. Like, there's a bunch of kids doing abacus, and it's great because they're all very excited. Yeah. Oh, Ghana. I'm so sorry. It's Ghana. Yeah. Good morning, Luca. Yeah. Yeah, yeah, I don't know about that one. I don't know. And then there's like this whole poll and gift vote. I don't know what that is either. And then, yeah, so, but it is what it is. How does the calculate, what? Sorry. How does the abacus compare to the calculator? Luca, you do it in your head. The calculator, you do it on a machine and it does it for you. So your head's your calculator. All right. All right. Thank you guys for joining for my live. I'll, I'll see you later. Have a good night. I'll see you in my next live. Bye. Okay. So, Luca, did that make sense? That what I just said? It was you do the calculations in your head and it's about brain gymnastics. That was fun. Yeah. Oh, see you later. Please elaborate. See you later, Sir Patrick. Please elaborate. We're tracking your right? So in the calculator, right, you have a calculator, you're going to do 1 plus 1 or 2 plus 2. When you do 2 plus 2, that's fine. But on the abacus, you visually see when you add 2. So we do 2 and then plus 2, and then we know that we have 4. So on the abacus, if I look, when we look, we have 1, 2, 3, 4. Thank you, Neon Panther. Yes, the abacus is more visual, whereas the calculator is just a calculator. Like you don't know. It's like using a calculator is like knowing magic, right? You just punch in a bunch of numbers, but then the question is, do you know how the numbers work? So when we're looking at on the abacus, we know that when we want to add the 5, we bring down the beat, so now we know this is 9. As opposed to on the calculator, do you know how it works? Right? You just have abstract numbers. When you have abstract numbers, it doesn't really make sense. You don't know how to get there, but you get there. Exactly. Exactly. So it's like a it's like a black box, right? You have your stuff and you put your stuff in there and it becomes a black box. And because it's a black box, then you don't know how it works. Like I know that there's electricity. I know when I turn on my light, right? Electricity comes up, but I don't know how it got here, right? That's above my pay grade. That's the difference. And it's the same thing with a calculator. So it's the same thing with my computer. Like I know I have a computer. I know how to turn on my computer, but do I know the inner workings of it? No. I don't know all the little nuances on how to get it because I'm not a computer developer or a computer builder, a computer engineer, right? It's the same thing, right? Do you know how a car works? We have a brake, we have transmission. If you're lucky, you might have a muffler, right? Computer scientists. I guess it's computer scientists that builds the computer. I guess so. So I don't know if Luca Donkey is still here, but after the fact, welcome back. After the fact, yeah, yeah. Computer science is a class. Yeah, computer science is a class. Way back in the day, it was like programming, but it wasn't building. We never build. Welcome back after the fact, Alex. Yes, welcome back. Um, but yeah, it's just one of those things. Like that's the difference. I don't know if Luca's still here. Oh, okay. You know, computer engineering. No, because that's like software engineering. Software engineering. That's software engineering. Computer engineering is like software. Oh yeah, you're welcome, Luca. Oh good, you're still here. Yeah, not a problem. Let me know if you have any more questions. But I am gonna sign off. I've been on for a live a little bit, and I'm going to something. Yeah, it is something. It's something. It's not an engineer because computer engineer is software developer, right? Have a good night. Okay, have a good night. I'm gonna sign off. This is it. I'm gonna sign off because there's people coming in and leaving. Okay, have a good night, Luca. I will hope to see you in my next live. And after the fact, Alex, I'll see you next time. I'll see you next time. Peace. Bye, Jose. I didn't know you were still here. All right. Have a good one, everybody. End